Hello my dear learners, I am Dr. Pawan Kumar Shukla, Professor in Electronics and Communication Engineering from RKGIT Ghaziabad. Today I am going to start the antenna fundamentals in the subject antenna and wave propagation. Till now whatever I have discussed in my previous lectures, that was all about the electromagnetic field theory. As we know that antenna is an extension of EMFT on the basis of electromagnetic field theory principles and all the fundamentals of EMFT, we utilize the antennas in the present world in the current era of telecommunications. So, today onwards my all the lectures will be dedicated to the antenna fundamentals, its parameters, its design and at last how these antenna work in the free space, in the environment, in our the present scenario of telecommunication, which is using the wireless communication, and most of the wireless communications are based on the antennas itself. So, let us start the antenna fundamentals. Before starting the theory of antenna, we always prefer to know about the communication system, because antenna is an essential part of any communication system, where the medium between a transmitter and receiver is free space. It means when the three basic components of a communication system as transmitter, channel and receiver, and among these three components the middle component channel is always free space. It means the transmitted signals are being propagated in free space through electromagnetic waves, and those electromagnetic waves are captured by the receiver. So, in this particular diagram, I have tried to make you clear each and everything which is related to antenna. If you understand this particular diagram, you will understand most of the things, the basic theory of antenna, how an antenna works. So, I am starting with the basic communication system. Generally, a communication system, as I have described earlier, it is having three parts: transmitter, channel and receiver. So, in this diagram we have divided this complete picture into three parts. The first part is, this is transmitter, this is receiver, and this one, this particular is channel. So, it is like a block diagram of a communication system, but in the communication system we generally prefer the other things which are related to the transmitter and receiver only, but in this diagram we emphasized the things which are related to the antenna only. If you see that this particular part where the generator or transmitter is written, this is only the part where the source, input or the signals which have to be transmitted are generator. That is why it is called as the generator of the message signal, generator of the input signal, and these message signal or input signal, they are mixed with the carrier, and all the things, all the operations, all the fundamentals are applied at the transmitting part, and when the signal is in the form of transmitted signal, then it is being transmitted through the transmission lines. Transmission lines are the physical mediums which are carrying the modulated or transmitted signal in the form of electromagnetic waves, and here these electromagnetic waves are being transferred in the form of electrical signal, and it is being carried out by a transition region. If you see that this is the transition region from here to here, this is the transition region, and this transition region associated with the transmitting part is known as the transmitting antenna. It is known as the transition region because the particular section of this transmitting part is used to convert the electrical energy into electromagnetic energy, because before this the energy was in the form of electrical energy in the transmission lines, and when it comes into the free space, it becomes the energy in the form of electromagnetic energy. So, it is known as the transition region, or this is the basic theory of antenna. And after that, this particular part is radiated the signals in free space, and this complete portion, when the physical contact is finished and all the radiations, all the waves, all the signals, all the energies are in the form of electromagnetic waves only. This is the region of free space, and in this region the electromagnetic waves are propagating. They are propagating through the atmosphere, they are propagating through the different layers of the atmosphere. We will study the same thing in this subject in the last unit. But here what happens after this? When these electromagnetic waves are propagating through the free space, at some point where the receiver is kept, the radiations are being captured by an antenna at the receiving side, and this phenomena, the aperture, the physical device is known as the receiving antenna, which extracts the electromagnetic energy from free space, and this is the part of that again transition region, and this transition region is receiving the electromagnetic energy from free space of a particular frequency for which this particular antenna is designed, and after that it is again transmitted through the transmission lines, and after that the receiver is capable to show, receiver is capable to demonstrate the energy which is being captured by the receiving antenna, and it goes through the transmission lines and receiver shows that energy. This is the complete system of a wireless communication link in which the role of an antenna is being described. Now, on the basis of that previous figure, we can define the antenna like this. In radio engineering, an antenna or aerial is the interface between radio waves propagating through space and electric currents moving in metal conductors used with the transmitter or receiver. As I have already told you that these antennas are the metallic or conducting structures which are capable to produce the electromagnetic waves with the help of the current density and charge density. The charge density and current density both are the responsible factors for generating the electric field and magnetic field, and the electromagnetic field is propagating the electromagnetic waves, and these electromagnetic waves are propagating in the free space through these antennas. So, these are some basic definitions of the antenna, but in the context of communication world, we can say that antennas are our electronic eyes and ears in free space, which recognize the energy, which is surrounding in the form of electromagnetic waves. No one can recognize this energy, but the antennas, like our eyes and ears, we can hear and we can see the energy. In the same way, these antennas can extract the energy from free space, and that is why we can say that they are converting the electrons into photons or vice versa, photons into electrons on the basis of transmitting and receiving antenna. This is the Thevenin equivalent of an antenna. It is important because we have to understand the basic circuit of antenna, how an antenna is connected to a transmitter, how an antenna is connected to a receiver, how an antenna works. That is why it is essential to understand the different impedances associated with the complete network of an antenna. You can see here that antenna impedance and the load impedance both are given in the form of voltage Vg and the impedance Zg. These are the source voltage and the source impedance. Source voltage and source impedance are written here because we have shown this diagram on the basis of transmitting end. Transmitting end means source, receiving end means load. So, transmitting end means from where the energy is being transmitted, and from that source where the energy is being transmitted is having the voltage as Vg, voltage source Vg, and the impedance as Zg. When this particular network is connected to an antenna, transmitting antenna, that transmitting antenna is having its own impedance like Za, which is having two components at the resistive and reactance component. The resistive component is Ra, which is also having two components. Ra means antenna resistance is having two components, that is radiation resistance and loss resistance. And in the same way, the reactance can be capacitive or inductive, both kind of. So, the purpose to show this Thevenin equivalent of an antenna is to make the understanding about the complete circuit including an antenna. Next, how many types of radiators which are proposed and which are being utilized in the antenna theory. The very basic and a very reference kind of antenna which is desired to describe all the parameters related to antenna is isotropic radiator. Isotropic radiator is a fictitious, it is an imaginary hypothetical kind of radiator which is defined as the radiator which distributes its all the radiated energy in all the directions uniformly. And when this complete radiated energy is distributed uniformly in all the directions, it means it is having no any directional characteristics. So, in other way we can say that an isotropic radiator is a worst antenna as far as its directional characteristics are concerned, but it is a reference antenna because it is not having any directional characteristics. So, when we compare with any practical antenna, we can say that that antenna is better, that antenna is much better, that antenna is best in that way. So, isotropic radiator is a reference antenna which is taken for defining all the parameters of an antenna. Anyway, directional antenna. So, isotropic radiator is a non-directional antenna, and all the practical kind of antennas are having directional properties, directional characteristics, because every antenna is having at least one preferred direction where its radiation is maximum. So, that particular direction for which the radiation is maximum is known as its preferred direction and the direction of maximum radiation. Next, isotropic radiator. This is the case of isotropic radiator where we can assume it like a sound source. Sound source is like that where the radiations are uniformly distributed. Here we have defined the isotropic radiator. So, you can understand by this diagram that how an isotropic radiator works in free space. In most of the cases, a transmitting antenna is always tried to be an isotropic radiator, because in the round coverage when a transmitting antenna has to capture a large number of receiving antennas, then it must have the tendency of being an isotropic radiator. Now, come to a very important, we can say one of the most important parameter of antenna, it is known as radiation pattern. Radiation pattern is a graphical representation of the distribution of power in terms of its direction. As we know that antenna theory is basically defined in the spherical coordinate system, and when a spherical coordinate system is defined on the basis of three coordinates like r, theta and phi. So, r is the distance at which that particular point is situated and theta and phi are the directional coordinates. It means theta and phi are the two bases for defining the directions only. Now, we will define the radiation pattern in terms of directions only. Radiation pattern is a parameter of antenna which does not depend on the distance factor or on the r factor, but it is totally dependent on the direction factor like theta and phi. It means the radiation pattern is a graphical representation which is drawn for the field or power. That is why there are two kinds of radiation pattern known as field pattern and power pattern. So, to completely specify the radiation pattern with respect to field intensity and polarization, it requires three kinds of patterns. You can see here. This is a basic diagram of radiation pattern. Actually, radiation pattern is a three-dimensional figure. You can understand it is a three-dimensional figure and it is a complicated diagram to draw, but in this case you can understand each and everything of a radiation pattern. For an antenna designer, the radiation pattern is a most important aspect, because this is the diagram which provides almost all the informations regarding an antenna. You can identify the directional characteristics, you can identify its on the basis of its shape, on the basis of its directional pattern, on the basis of its impedance, everything can be defined on the basis of radiation pattern. So, this is the three-dimensional diagram where this particular part, the main part, it is known as the major lobe of the radiation pattern, and all other parts are defined as the minor lobes, side lobes and back lobes. You will understand in the next diagram. These are the different lobes, as I have shown in the last figure, that various parts of radiation pattern are referred to as lobes. Whatever the areas or the regions are defined for the distribution of power or distribution of electric field, they are known as the lobes, and these lobes may be of major type, side lobe type, minor lobe type or back lobe type. All the definitions for all these kinds of lobes are given. The back lobe is that small lobe, small portion of the distribution of energy just opposite to the major lobe. Side lobes are the adjacent of the major lobe, and minor lobes are described all other lobes except the major lobe. Next is the beam width of an antenna. The shape of a radiation pattern is defined with the help of beam width. What is beam width? Beam width is this particular portion. The sharpness of the major lobe of the radiation pattern of an antenna defines its directional characteristics. Sharpness. The sharpness is the parameter, sharpness is the theme for defining the beam width of an antenna. जितना ज़्यादा शार्प उसका मेजर लोब होगा, उतनी ही अच्छी उसकी डायरेक्शनल कैरेक्टरिस्टिक्स होंगी. The shape of the different major lobes we will study in the next slide, but here you can see that the different shapes, the different sharpness are described for the major lobe, and for describing the beam width there are two parameters. First one is half power beam width and second one is the beam width between first nulls. So, beam width between first nulls is the beam width between the adjacent side lobes, is the angle, the solid angle between the two side lobes, and the half power beam width is the beam width at which the power is 1 by 2. And in the same way we can understand when the power is 1 by 2, then the electric field is 1 by root 2. Here from this diagram you can understand all the things. These are the types of radiation patterns and the linear plot of power pattern. Radiation pattern, linear plot of power pattern, you can understand that what is HPBW and what is BWFN, and the side lobe, back lobe, major lobe, what is the position, and when we describe it in a complete cycle means 0 to 360 degree, then the different a complete sphere can be taken different parts of this particular radiation pattern, and it is given in this diagram. Normalized pattern means when we take the maximum value of the radiation pattern as unity 1, then the all other kind of patterns can be defined on the basis of this normalized pattern. And you can understand that this particular formula or this particular portion is given to make it clear that how a normalized pattern works. Normalized field pattern and normalized power pattern, you can understand as I have already discussed that when the power is half, then the electric field becomes 1 by root 2. 1 by root 2 means 0.707, and this is the difference between the power pattern and the field pattern. So, you can draw the radiation pattern on the basis of this. These are the principal patterns on the basis of E and H. Obviously, E field pattern and H field pattern both are very important patterns when we describe it on the basis of two dimensional diagrams. Single principal pattern of E field or single principal pattern of H field are two dimensional figures, and these are described on the basis of when the xz plane means elevation plane, when phi is equal to 0 is the principal E plane, and the xy plane when azimuthal plane when phi is equal to pi by 2, it is the H plane basic principal pattern. So, I just want to say thank you to all of you for watching this video. In my next lecture, I will explain the other parameters of antenna theory. Thank you very much.